Hello, you are most welcome. I'm teacher Ivan from WUNNA Educational Services. I welcome you to this particular lesson where we shall be looking at density and relative density. We shall start with density. Density is defined as the mass per unit volume of a substance. If they ask you to define density of a liquid, then you simply define it as the mass per unit volume of the liquid. And therefore, from that definition of density, we shall get the formula and the units of density. Density is denoted as rho. Rho is the symbol for density, which is given by mass m over volume v. Therefore, mass is measured in kilograms and volume is measured in cubic meters. So when you divide kilogram by cubic meter, that's when we get the SI unit of density as kilogram per cubic meter. This negative sign is showing the division of kilogram and meter cubed. We shall not use the slanting slash, but we shall use the power. And therefore, besides the SI unit, which is kilogram per meter cubed, we also have other unit of density. When mass is measured in grams, volume will be measured in centimeter cubed. And that gives us the other unit of density, which is grams per cubic centimeter. It means that whenever we are considering mass in grams, we should also consider volume in cubic centimeters. But don't say kilogram per cubic centimeter or grams per cubic meter. No, kilograms will go with meter cubed, because they are all SI units. And then grams will always go with centimeter cubed. We have a note which says that to determine the density of a substance, we must have the mass of the substance and its volume. Then we obtain the density using the formula. And that implies that density is a derived quantity, derived from mass and volume. So, for instance, if I want to get a density of a stone, I'll get its mass using a beam balance. I'll get its volume using either displacement method or overflow current method, and then divide the mass by volume to get density. Let's continue. So, after looking at the two units of density, which is kilogram per meter cubed and grams per centimeter cubed, then we shall have conversion of units of density, where we shall look at how we change from kilograms per meter cubed to grams per centimeter cubed, and also from grams per centimeter cubed back to kilograms per meter cubed. So, kilogram per meter cubed means that we are dividing 1 kilogram by 1 meter cubed. But 1 kilogram is equivalent to 1,000 grams. And 1 meter cubed is equivalent to 1 million centimeter cubed. And therefore, when we divide, we shall end up with 1 kilogram per meter cubed being equivalent to 1/1000 grams per centimeter cubed. So that's how we convert from kilogram per meter cubed to grams per centimeter cubed. It means that we shall always divide our values by 1,000. Then we look at the equivalence of 1 gram per centimeter cube in terms of kilograms per meter cubed. So we shall simply continue from here, where we shall multiply through by 1,000. When we multiply through by 1,000, we shall get 1,000 times 1 kilogram per meter cubed, equaling to 1,000 times 1 over 1,000. So this one will cancel and give us 1 gram per centimeter cubed, being equivalent to 1,000 kilograms per meter cubed. Now, here is where it confuses many of us. For us, we think since a kilogram is bigger than a gram, we shouldn't get 1,000 kilograms per meter cubed. Please, the determinant is not the kilogram and gram. The determinant is the centimeter cubed and meter cubed. Remember, as we were converting the 1 meter cubed to centimeter cubed, we got 1 million. So this 1 million reduces the 1,000 grams to 1 over 1,000. So in this conversion, the determinant is majorly the centimeter cubed and meter cubed. That's why we have 1 gram per centimeter cubed being equivalent to 1,000 kilograms per meter cubed. And maybe let me explain what this means. 1 gram per centimeter cubed means that we have 1 gram in the volume of 1 centimeter cubed. And here we have 1,000 kilograms in a volume of 1 meter cubed. Remember, 1 meter cubed is larger than 1 centimeter cubed. And therefore, since it is larger than 1 centimeter cubed, it will contain more than this. Hope we are now together. Let us look at examples. Examples of conversions. However, before we look at examples, I want us to summarize this. When converting from 1 kilogram per meter cubed to gram per centimeter cubed, we divide by 1,000. While when converting from grams per centimeter cubed to kilograms per meter cubed, we multiply by 1,000. For instance, part A, we are converting 0.8 grams per centimeter cubed to kilogram per meter cubed. So we shall multiply by 1,000. Since 1 is equivalent to 1,000, so we multiply to get 800 kilograms per meter cubed. Let us continue. In example 2 is where we have 900 kilograms per meter cubed to grams per centimeter cubed. We've seen that when changing from kilograms per meter cubed to grams per centimeter cubed, we divide by 1,000. And therefore, 900 will become 0.9 grams per centimeter cubed. If we are together, let's try these few numbers. Otherwise, I'm teacher Ivan from WUNNA Educational Services. Please subscribe to all our YouTube channels. They are down on our homepage of this YouTube channel. You scroll down, you find them, subscribe to them. We have Teacher Ivan's online class. We have WUNNA Math channel, WUNNA Kids platform. Subscribe to them so that we enjoy the learning conveniently from any place at any time. Otherwise, we are on TikTok, Facebook, we are on X, Instagram. Just search for WUNNA Educational Services. Join us, follow us, so that we learn together as we enjoy together. Bye-bye.